Hello and welcome to Water Quality. In this video, I'm going to go over an example of precipitation using stannous fluoride as an example. And we have stannous fluoride dissolving into water, and I've shown the reaction for that. So the precipitation dissolution reaction, where stannous fluoride dissolves into stannous and fluoride ions. And I have the equilibrium constant, the KSO value identified at the top. Okay, so first I'm going to solve the solubility in deionized water and then in a lightly salty solution with fluoride as the common ion, and then in a more salty solution where the ionic strength effects become important. Okay, so first we'll solve the solubility in deionized water. And I have two containers of water here shown, and they're actually they're the same containers, but just separated by a time step. So imagine in the first container, I don't have any stannous. So I can call this stannous initial, and there's no stannous, and there's also no fluoride because it's deionized water. And then I'm going to add stannous fluoride, one molecule at a time, miraculously, until the solubility limit is reached, such that if I were to add another molecule of the stannous fluoride, it wouldn't dissolve, but it would stay as a solid, be a precipitant in the solution. So that's my solubility limit. And one important thing to note about this problem is because there's a single stannous but two fluorides for every molecule, it means that my fluoride concentration is going to be equal to 2 times my stannous concentration. And so here I'll have a stannous, and it's all added by the solid being added to the solution, and my fluoride will be 2 times that value. To solve this problem, I'm going to use the mass action equation with the equilibrium constant. So I have KSO is equal to stannous times fluoride squared. And the stannous fluoride solid doesn't show up in the equilibrium equation because solids are 1 in those equations. And I'm not having any ionic strength effects here, and temperature 25 degrees C, standard temperature, no ionic strength effects. And the reason I don't have ionic strength effects is because I'm starting with deionized water and kind of making the assumption that the amount of stannous fluoride that dissolves is going to be pretty small. Okay, so let's check that out. So I have my stannous that I'll leave as the variable, and I'll replace the fluoride with 2 times stannous, and this is squared. And I have my KSO, which is 1.8 times 10 to the minus 9. So I solve that, and I end up with a stannous concentration of 10 to the minus 3.11 moles per liter, or 0.00077 moles per liter. And then my fluoride, I can solve that also. The problem's asking for solubility, which I'm going to take to be the stannous concentration, but I'll solve this as well. And this is 2 times the stannous. So I have a value of 10 to the minus 2.81 moles per liter. And so my solubility, which I'll call S, is the amount of stannous fluoride solid that dissolved into the solution, so I'll call that dissolved, which is equal to the amount of stannous dissolved in the solution, which in this problem is 10 to the minus 3.11 moles per liter. And that is our answer of solubility of stannous fluoride in deionized water. In the next video, I'll show you how to solve this problem in a lightly salty solution with sodium fluoride.